Hello students. In this video we are going to study about Unit 5 or System Programming called as a compiler. Again this chapter I divided into two parts because it's too much lengthier. Topics are existed in this chapter to be discussed. So in the part A the topics to be discussed are like this. Statement of a problem. Problem number 1. Recognize basic elements used in the compiler. Problem number 2, recognizing syntactic units and interpreting their meaning. After that, we need to study intermediate form. Problem number 3, storage allocation. Problem number 4, code generation. In the code generation, we need to study optimization with respect to two things. One is with respect to machine independent and another one is with respect to machine dependent. Next one is assembly phase. After that, we need to learn a general model of a compiler. So generally, there are different types of compilers with respect to the programming, higher level programming. So here we need to learn about general model. In the phase part 2, the phases of compiler has to be studied and it has several different topics that will be discussed in the next video. According to Bangalore University Blueprint, 2 marks 2 questions will be asked. 5 marks, one question will be asked sometime in part B, or sometime two questions will be asked in part B as well as in part D considered. 15 marks, one question. 15 marks question will be divided into two parts. 7 mark one question and 8 mark one question, totally 15 marks. And there is a possibility in section D sometimes there may be a there they will ask 10 marks one question, so or 5 marks one question, so totally 34 marks question will be asked from this chapter called as a compiler. 34 marks, 10 marks 1, 15 marks 1, 10 plus 15, 25, 25 plus 5, 30, 30 plus 4, 34. So moving to the next, the content to be discussed in this compiler in terms of two things. The entire compiler design will be divided into two structure. One is called structure of a compiler, another one is called design of a compiler. So in the structure of a compiler, we need to define statement of a problem, and with respect to that, whichever the subtopics will be appear to define a structure of a compiler that we are going to be discuss. So before going to start a definition of compiler, I wanted to give some basic information. So we know that computer have a decision making device called as a memory. So each and every time whenever higher level programming or lower level programming will be used in the computer, it can't be understandable by the machine because computer is a machine. It can't identify a lower level code as well as the higher level code. So for that, it's our duty to convert higher level or lower level language in terms of a machine readable form. So for that we require a translator or a transformer. Those will convert such kind of a language into a machine readable form. So actual form of an data which you are giving in terms of an high or low level will be called as a source program, and which it will convert with the help of a translator that is called as an object code. So there are three different types of an translator, compiler, assembler, and interpreter. So compiler and interpreter will be used for the compilation or translation of higher level programming language into object code, but the assembler will be used for low level language translation into object code. So now we will learn what is compiler. A compiler is a program which helps you transfer source code written in high level language into a low level machine language. So totally whichever the program you written in higher level programming language, that will be converted into machine level language, and that machine level language is called as a low level language. It translates the code written in one programming language to some other language without changing the meaning of code whichever the program you used for developing a source code, without changing that meaning of the actual program used in different programming language will never change. So with respect to the same code, whatever you written in the program will be converted into object code without changing its meaning. The compiler also makes the end code efficient, which is optimized for execution time and memory space. The compiler also makes end efficient, which is called optimized execution time and memory space. So it won't face any problem with the memory space as well as execution time. So this is the small picture. It represents how the compiler works. This is the compiler. It is called as a program, one of the system program. What it will do, it will accept input as a high level language, convert it into low level language. If any error occur, that errors during the compilation will be called as a compilation error. Who has to debug all these things? This compilation error has been evaluated by programmer or by compiler itself, and finally it will produce a one program as output. That program itself is called as an object program. Language processing technique for the compiler. So there are two types of a language processing technique. One is called front end, another one is called back end. The front end checks whether the program is correctly written in terms of programming language syntax and semantics. There are some rules and regulations. Depends on the rules and regulation used by the respective programming. The input is written by the programmer is correct or not. That will be checked. This kind of checking is called as a front end. Back end. It is responsible for translating the source into object code, that is nothing but assembly code. Again, it is in terms of an assembly code, mnemonic code. It cannot be understandable by the user. So the backend will be responsible for translating all source code into a assembly code. And which phase will be considered as a front end processing technique, and which part will be considered for the back end processing technique, that we will see. These are the phases of the compiler: lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, target code generation. And lexical analysis, syntax analysis, semantic analysis, intermediate code depends on its machine structure. These will be performing, so that's why it is called as a front end. So with respect to the programming, with respect to the procedure, with respect to the rules and regulation, is called as in syntax and semantics of the programming. It will check entire whether the written code is correct or not. Code optimization, target code generation, that is nothing but so memory allocation is done properly or not, any problem during the conversion of the memory addressing, everything will be taken care by code optimization. And finally it will generate a target code called as an object code, so that will be called as an backend uh, machine dependent. Sorry, here machine independent. Here it is not dependent on the machine structure, it is dependent on the programming which you are using. But here these two are dependent on the machine structure, because these two are with respect to the machine structure, they are going to be defined. Moving to the next. Next statement of a problem has to be defined with respect to the compiler design. A sample programming language interface program is taken as an example. The overall task performed by the compiler is going to be checked with the help of this small code. And this programming cannot be known by you people. There is one basic programming called as an Lisp programming. In the Lisp programming, the syntax is going to be written like this. So this is the declaration. So these are the variables are declared with the fixed binary type of an data with a size called as an 31, and that is storage location whichever it is defined for these variables are of static storage allocation. And this is the expression, cost expression has to be evaluated by the same variable. And here they defined a procedure with the three different variable called rate, start and finish. And after evaluation of this cost, it has to return back and this procedure has to end. So like this, the program is defined in the programming called as a Lisp program. So now we don't want to discuss about what is Lisp, why they will use like this definition for the definition defining the program. There are different types of a program with respect to their syntax and semantics. The program will be written. So next, how it will perform a compilation that we will see. The compiler should perform the following four tasks to produce the equivalent machine code. So first it has to recognize certain strings as a basic elements. After that it has to recognize syntax, that is nothing but grammar. In automata, in theory of computer, you studied grammar. The same manner here you need to find out a grammar used to represent this type of a symbol that is called as a syntactic units. Syntactic is nothing but it is a syntax and semantics used by the programming language which you chosen for writing the code and interpreting their meanings. So whichever the syntax and semantics you used to interpret their meaning, we are using second step. Third step, allocate storage and assign location for all variables in the program. For example, here three variables are there, rate, start, finish. So allocation of the storage for each and every variable has to be done in the program. After that, generate appropriate object code. So there are four phases. First, recognize the basic elements, that is nothing but tokens, that I will come to know you in the next slide. And after that, we need to recognize what is the syntax and semantics for that programming and relate to interpreting of their meaning we have to recognize. After that, allocation has to be done to the variables which you used in the program. Later, finally, it has to produce a object code. Here first we will take problem number 1 as in recognizing basic elements. Here the step 1 and step 2 will be discussed with respect to the problem which we considered as one of the example in the previous slide, Lisp program. So in the step 1, the source program is scanned sequentially and broken into pieces or blocks of program that is called as a basic element, or we can say token. The entire source program is sequentially scanned and it will be broken into smaller pieces or smaller blocks, and those smaller pieces or blocks of a program itself is called as a basic element of an source program, and the same thing can be called as an tokens. Each token represents a sequence of characters treated as an one entity. When you are breaking entire program into smaller piece, a small piece of an program is representing a sequence of characters and it will be treated as an entity. They are the smallest program units that are individually meaningful. Whichever the block you made, whichever the pieces you made for the entire program itself are representing its individual meaning. The blanks separating the characters of the tokens would normally be eliminated. Whenever the blanks will be used in the program, those will be eliminated by because those are the separating characters. Next one, example, with respect to the previous program, this program, here, how we are going to recognize and identify what are those. WCM, the beginning of the word count machine. This is the one name given to the procedure, word count machine. This word count machine, rate, start, finish, etc., whichever you used in the program, are recognized as an identifiers. Those are nothing but variables. Procedure as a keyword token. This cannot be used for identifier. Here also the same rule. And comma, colon, bracket, colon, semicolon, etc. used in the program are treated as a terminal symbols. These will be treated as a terminal symbols. Next, to perform all these conversions, we require lexical analysis. The action of passing the source program into the proper syntactic classes is known as lexical analysis. What do you mean by this lexical analysis that we need to learn? So the action of parsing is nothing but converting from one program to one type of code into another type. The conversion of one form of a program into another form of an program, there is a rules and regulation with respect to that the entire source code is written. Without changing the meaning of that, the entire procedure has to be converted into object code with its syntax and semantics. Such kind of a syntactic class is called as an lexical analysis. In the step 2, the basic elements are entered into the table. So in designing of an assembler, you saw each symbols will be stored into the table in the same manner. Here also basic elements are entered into the table. Since the information of the basic elements are required by the other phases of the compiler, so for that each and every information will be stored in terms of in tables. And information about the tokens are entered along with the data type, precision, length, and storage class, everything into the table. For example, consider one statement, WCM procedure, rate, start, finish is the procedure with the three variables, and this is the procedure name, WCM. So what it indicates, the above source string itself is converted into a string of uniform symbols. The entire statement will be converted into itself in terms of an uniform symbols. The uniform symbols are of a fixed size and consist of syntactic class and a pointer to the table entry of the associated basic element. In the table, whichever it is there, there is a pointer. It will point the table entry and associated with the basic element defined in the table. And it consists of a fixed size, and those will be stored into the table called as an symbol table or literal table, and these will maintain uniformity. So that's why these are called a string of uniform symbols. The meaning will not be changed. Problem number 2, recognizing syntactic units and interpreting their meaning. So whichever you considered the program statement that has to be recognized with the syntactic units and it has to be interpreting, that is nothing but converting into the object code. Once the program blocks are broken into tokens or uniform symbols, the compiler must recognize statements or syntactic constructions. That is nothing but recognize the phrase. After that, it has to interpret the meaning of the construction which you recognized. In the first step 1, we will take the same one, recognizing the phrase. The compiler checks for the validity of each and every phrase or statement defined by the program. If the statement is free of errors, then the statement is declared as a valid statement. If the statement has any errors, then the compiler assures some sort of recovery. Then it is nothing but it will provide a error message and continues with the compilation errors of the next statements. Like this it will process. In the step 2, how it is going to interpret the meaning of construction. Once the syntax of the statement has been ascertained, the second step is to interpret the meaning. That is nothing but semantics. Rules. Say, with respect to semantics, syntax, whichever the rules are applying for the conversion of the statement used or written by the user in a higher level language. Each syntactic construction is associated with defined meaning. Each and every syntactic construct has its own defined meaning. Syntax analysis. The process of recognizing and separating the syntactic construct and interpreting their meaning is known as syntax analysis. What is the syntax analysis? The process of recognizing the separating the syntactic construct and interpreting their meaning is known as syntax analysis. Each syntactic construct is associated with a defined meaning, which is in the form of an actual code or intermediate form of the construction. Syntactic constructs are recognized using two general methods. One is called reductions, another one is called action routines. Reductions are the rules that specifies the syntax from a form of the source language. The action routines, after defining the syntactic construction by the reduction, appropriate compile routine or action routine are executed when a construction is recognized, is called as an action routine. For example, this is the one statement used in that sample program. This is called as an variable attached with the equal sign. The reduction will specify that any identifier is followed by equal sign. This is called as a reduction. Then call the action routine arithmetic statement. This is called arithmetic statement. Here multiplication, subtraction, addition is performing with the single statement of a mathematical instruction. So that's why this is called as an action routine, has to be performed and it is assigned with the variable, and this variable is called as an reduction because this is attached with the equal sign. Next, intermediate form. The process of generating the object code for construction after determining the syntactic construction is known as intermediate form. What is that? Generating the object code for each and every construction after determining the syntactic construction, syntax and semantics. With respect to syntax, it is going to determine the object code for each symbol and it has to be defined. With respect to that, we have to take care of the rule of that one. Then such kind of a process is called as an intermediate form. It should not change the meaning while converting from one programming language into other programming language. The meaning has to be remain same. The syntax and semantics will be changed according to that programming, but it should not affect the meaning of the instruction or the code. Advantage of intermediate form. This facilitates optimization of object code. It allows logical separation between the machine independent phase as well as machine dependent phase. The intermediate form depends on syntactic construct such as arithmetic statements, non-arithmetic statement, and non-executable statements. Arithmetic statements. One intermediate form of the arithmetic statement is a parse tree. Parse tree you know very well. In the data structure you learned it seems. Or in automata also you studied in theory of computers. The rules for converting arithmetic statement into parse tree are like a binary tree. Any variable is a terminal node of a tree. Second one, for every operand, construct a binary tree whose left branch is the tree for operand 1 and whose right branch is for operand 2. How you are saying root, left child and right child in the binary tree. In the same manner here we will say the first terminal node of a tree is a variable and for every operand, construct a binary tree whose left branch is operand 1 and whose right branch is operand 2. Uses. How to use that operators if it is existed in the programming statement. Highest priority will be given to the expression. It is within a parenthesis. Second priority will be given to multiplication and division symbol. Third priority will be given to addition and subtraction. If the sequence of the operator is same, for example, plus minus are existed in the same statement, then start solving from left to right. We should always consider the evaluation of the mathematical expression from left to right in the computers. So consider one example, A equals to B plus C. So this is called one equation. This I need to represent with the help of parse tree. Equal is there, so I written A equals. So here A equal to X I will take. A equals X. X is not single. Again it is a combination of B plus C. So always operator should be considered as here a root, and the operand should be considered as an right and left operand. But in the right operand, again that operand is expanded with the B plus C. Again this middle operator will be considered as a root, and other two are called as a child, and this is called as an interior, and this is called as in children. This is also called as in children, but children will be treated as in here a plus symbol. So now I will say A, B, C are the children for the parse tree plus and equal. So like that one example for a expression start minus finish minus 100. So start and finish. So before this, what I need to specify, all are existed in the same start and finish I defined. Again minus has to be defined. I can't define here. I should consider here minus equals to. It will process from bottom to top. So in the same manner here, I gave one example, cost, the same statement which you used, cost equal to rate into start minus finish plus 2 into rate into start minus finish minus 100. So I need to start from left to right. So I will consider this is my left side, this is my right side. From here, this is the first appearance of the parenthesis. I need to solve this one. Start minus finish minus 100. Next, moving to the next one, into rate. Into rate. Here again, I have two multiplications, into rate. Into rate. Along with that, I need to multiply 2. So into rate and 2. After that, I will move towards the next operator, plus again it is followed by a parenthesis. First I will start with the parenthesis start and finish with the minus operator, and it is multiplied by a rate. So multiplied by rate, and this equation evaluation will give a value that is equal to a cost. Like this, the meaning of an parse tree is going to be given, and in the same manner the compiler is going to be convert your entire source code into a object code. Moving to the next, non-arithmetic statement. The statements like do, if, go to, etc. can be replaced by a sequential ordering of individual matrix entry. This is the matrix. Operator, operand 1 and operand 2 are defined. I took two examples. Return cost, it is there in the program, and it is defining a operator called as an return, and operand as an cost. And it is the operator, it will indicate end of the program. Non-executable statements. It declares the compiler information that clarifies the referencing or allocation of the variables and associated storage with respect to the statement. And there is no intermediate form of the statement in non-executable statement, but the information contained in a non-executable statements is entered into the tables, and to be used by other part of the compiler during the compilation. For example, declare cost rate, this is the one of the statement, how it is going to be defined. The fixed data type of this one is fixed binary, and the length of this entire variable is of 31 bits length, and it will be having static storage device. Like that, the meaning is going to be defined with a statement called as an declare. Cost is a fixed binary type with the 31 bits size of a static storage like this. Rate is a fixed binary data type of 31 bits with static storage. Like this, we have to define. Next one, problem number 3, storage allocation. The storage allocation routine scans the identifier table and assigns location to each variable like symbol table. The data type of each variable of a fixed binary with respect to that program which we consider is 32 bits. The relative location will be start from 0 is assigned, and the next to that 32 bits is nothing but 4 bytes. So 4, 4, 4, 4, 4, increasing 4 bytes, the location will be measured. There is a 1 bit called as a storage class. The allocation is done at the time of compilation. Only static storage classes can give the details of the entry in their identifier table like base, scale, precision, and then then reserves the proper amount of storage. These kind of an information will be stored in a particular table that is called as a storage class. There are different types: static storage class, automatic storage class, controlled, and based. In the static storage class, the default storage class for externally compiled subroutines and the main program will be stored. In the automatic storage class, the variable in a procedure that will not be retained once the procedure is over. So those information will be stored. In controlled, common block variables. Controlled variables are protected against being used in ways that may cause interference. Those will be stored into the controlled class. Based class, they cannot be assigned the same way as static storage class will assign the value. The object code is generated for the statement such as procedure, begin, all these by the compiler, not like a static storage class. Problem number 4, the last one, code generation. Once the matrix and supporting information has created, the compiler now can generate the object code. Each type of matrix operation with associated object code is defined by a table called code production table. So the code generation phase scans the matrix and generates the code for each entry defined in the table using the operands of the matrix entries what it is made in the symbol and literal table. It generates standard code definition for operators. Appropriate code is generated using standard code definition. The input is the matrix for code generation phase, which defines the operators that may occur in the matrix to produce the code. It also references the identifier table and literal table in order to generate a proper address and the code conversion, whichever it is done with the help of compiler during the compilation of source code into the object code. So after this, we need to learn a designing model of an assembler. Before that, we need to learn optimization. Machine independent and machine dependent two optimization will occur in the design of a compiler. Removing or deleting the duplicate entries in the matrix and modifying all references to deleted entries is one type of a machine independent optimization that is called machine independent. Why? Because other machine independent optimizations are also like this: compile time computation of operations, both of whose operand are constants. Moment of computations involving non-varying operands out of loops. Use of the properties of Boolean expression to minimize their computation. Sometimes some variables will be defined, will be fluctuating in its value, that is called as a variable, not identifier. At that time, the removing and deleting of and duplicate entries to the matrix with the modifying all references of their deleted entry is itself is called as a machine independent optimization because it is with respect to the machine structure is happening. So that's why it is called as a machine optimization, machine independent optimization. Another one is machine dependent. So the improved version of code is better code that used less storage and is faster due to more appropriate mix of instruction. This is possible due to better use of temporary storage using any of the 16 register that could be used by used and by not storing intermediate results unless until they were absolutely necessary. This reduces the number of load and store operations. Also, where possible, shorter and faster instructions where such kind of a machine dependent optimization will be used. This phase has reduced both memory space and the execution time of the object program. Since these two factors is dependent on machine, this type of an operation optimization is called machine dependent optimization because it is dependent on the structure. It is not dependent on the structure. It is dependent on the structure because in the beginning I made a mistake. So it is not dependent. Why? Because it is with respect to the variable length, variable size, what you defined, according to that it will fluctuate. But this is with respect to the machine and the machine structure, it is going to be evaluating. Sorry for that. Next, assembly phase. The process of generating the actual code itself is called as an assembly phase, that is object code. The code generation phase is producing assembly language. The compiler is generating references to actual code in place of literals and variables assigned by a storage location. Routine itself is called as an assembly phase. The assembly phase must resolve the label references in the object program, format the appropriate instruction for the loader. If the code generator simply generates symbolic machine names, instructions, and labels, the assembly phase must resolve the label references, generate binary machine instructions, convert all literals, calculate the addresses for the literals, and generate the storage. All these process has to be resolved by the assembly itself. If the code generator simply specifies the symbol names, instructions, and labels, if it is not, then obviously the assembled uh, code it is going to be produced for the loader depends on that instruction. Loader will load the entire instruction to the memory for the process of execution. So like this, internally the compiler is going to be process its task with all these phases. So in the next video we will see about how the designing of a compiler structure is defined. To define that structure of a compiler, which and all phases are included to perform a task called as an compiler design. I think through this video you came to know that how the compiler design is going to be performing through all these steps. If any doubts, feel free to ask me through this. This is my personal email ID. Uh, Fire or trigger your questions to the mail ID. I will respond back you as soon as I will get your question. Thank you. Thank you.